Hello friends, welcome to our channel. Here we are going to look at today's daily challenge problem. Total characters in string after transformations. This is a series of problem 1, right? So in this video, we are going to use a very elegant treatment. So the method here will be use a queue to do queue shifting to monitor the changes. So this is exactly suiting the problem requirement. So I hope that this coding will demonstrate the power of this this problem reduction, right? So here we are given a string s and an integer t. So we want to do t times the transformations. So the transformation is the following. So we are going to map a to b, b to c, and so on. But for z, we want to map it to be a string ab, right? So we want to return the length of the resulting string after exactly t transformations. Since the answer might be very large, so we are going to return the length modulo this big prime number. So here you can look at the two examples to get the output, then get the length. Here the length it can be as long as 10 to the power 5. Therefore, we need to think of time complexity, or we need to think of the method efficiency, right? For this problem, the key assumption is here, actually. S consists only of lowercase English letters. So this assumption actually makes us able to do it in a very elegant fashion. Let me write this code and explain later. So first, I'm going to use a collections deck. So here for this deck, I'm going to have have a length 26. So this is from the assumption here, right? So this item, lowercase English letters, there are 26. So we are going to monitor the frequency of each letter during this process. And then later, at the end, we just need to return the sum of the frequency. So for index 0, we're going to store the frequency of A. Similarly, for index 1, we're going to store the frequency of B, and so on. So first, I'm going to get a reference frequency. So here, I'm going to use this ordinal number to achieve that goal. So basically now, for I in S, so actually, let's write it for character in S, right? So here, let's first get its relative index. So the index will be the ordinal number of this character minus that of A, right? Then we're going to do Q. At this index, I'm going to increment by 1. So you can print out this Q. For the first example, it means, A appears once, B appears once, C appears once. So this is the A, B, C. And Y appears twice. So that's the Y, right? So with that information, so we can mimic the process. So here basically is a for loop. For T, here I'm using T, but I will just use a dummy index. So for this in range T. So here I'm going to use a Q pop operation. So this Q pop operation is going to pop on those. So then this is going to treat. So I'm going to shift A to B, and B to C, and Y and C to Z, right? And then next we are going to treat Z change to be XY. So in order to make that, so what shall we do? So we do Q append left, right? So this Z is actually the number of character Z, right? In the string S. So then it will change to be Z of A and Z of B. So this you append to the left. So this corresponding to the index for A, right? And then what we do, Q1 is incremented by that of z. This is the number of b added, right? So this add same number of a to the queue head, same as the number of z, as the frequency of z, right? Or same number of z. So here I add this the comment to make it clear. So here we add same number of b to the count for b, right? That's the index 1, right? So same number, the same as the previous frequency of z. So this will treat all the cases. So now what we want to do is to return the sum of the queue modulo this big prime number. So this will be the solution to this problem. Personally, I feel this solution is very elegant. So now let's first run it. Yeah, it passes the first two cases. So now let's look at the generic case. Yeah, it passes the generic cases. So here I want to mention to you that, so this is largely this hint, right? Here, maintain the frequency of each character and then do the transformation. But the transformation actually corresponds to this one, right? This pop will change A to B and B to A after we add this this part, right? And then you will get this two. So I would say, so here I'm going to mark it. This is line 1, and this is line 2 of the code. This is line 3. So line 1 plus line 2. So treat A to B and Y to Z. So 2 plus 3 treat Z to AB, right? So here all those A, B, Y, Z, and Z are the characters, right? I didn't don't be confused with the count or frequency here, right? So here it would be good you write frequency, but I write Z is also good because you can, because it's Z, it's represents the frequency of Z in the original state before the new transformation. So with that said, I guess that's it for the current problem and the current video. You are welcome to check out other videos in the channel. For now, I guess it's more than 1,000 carefully and rigorous prepared YouTube channels from my notes. And there are more than 20 playlists that you can also do some practice according to the list. So this way, you will do the problem. You can do the problem using different methods, or you can using a same method to solve a different problem. So this make it more make it more versatile. So I guess this kind of way for doing the practice helps a lot. Thank you for watching.